Alright, since you're going to have a quiz, let's talk about solving systems of equations graphically. It's a really quick graphing quiz. So here, this time to change it up, I'm asking you to draw me an example of what a graph would look like if it was consistent, inconsistent, and dependent, and then justify why your graph represents that type of system. So let's start off with consistent. Remember, consistent graphs have at least one solution. So I need to just draw a quick sketch. Let's just draw something that looks like this. Terrible line. Sorry guys, you know that. But you can use your ruler. And there we go. One solution right in the middle. So this would be considered consistent. Yesterday, if you remember on our lesson, we saw some that were inconsistent. Inconsistent means there's just no solution at all. These guys should look parallel. We're going to call that inconsistent. My lines are parallel, which means there's no solution. And then this is the last one. The dependent's the hardest, I think, to graph because there's actually two lines graphed, but you're only going to see one of the lines. So, infinite number of solutions. Be sure you guys, that looks like an F. I-N-F-I-N-I-T-E. Infinite number of solutions. So lines are exactly on top of each other. So you can only see one line, but there are actually two. Alright, one quick review question in terms of graphing, and that's it, and then we're good to go. Alright, here we go. Alright, so on your quiz, if you were asked to solve this system graphically, first thing I have to do is graph both lines. I'd love to do that, but I can't because this first line is not in y equals form. So that's one of the steps we're going to have to take in order to get that y by itself. I would recommend, especially since we do have a quiz tomorrow, I recommend pausing the video right now, trying this question on your own, and then coming back and checking with me and watching the rest of the video. I think it's really important that you practice on your own. If you're not feeling confident right now, even just solving them, that's okay. You can always pause the video at any point and work on the graphing on your own. Okay, so again, I want to get my y by itself. So I have to get rid of this 2x and the negative 3 in front of the y. So in order to get rid of that 2x, I have to subtract 2x on both sides. My equation will now say negative 3y equals negative 2x plus 3. And again, one more time, getting rid of that negative 3. A little bit of dividing to do on my calculator. Negative 2 divided by negative 3. If I put this into my alpha y equals, I'm going to end up with the fraction 2/3. So a negative 2 divided by a negative makes a positive 2/3. And then a positive 3 divided by a negative 3 is going to get me negative 1. So my slope is 2/3. My y-intercept is going to be negative 1. Again, this is another time to pause the video if you want to try this second equation on your own. Try to get it into y equals first before we graph it. So again, this is a good time if you need to pause the video and try solving this one for y on your own. Alright, if you're sticking with me, then maybe you need some more practice. That's okay. I'm going to minus 4x on both sides. What's going to be left over is negative 6y. Rewriting that right side in standard form, the x in front, the 24 in the back. And then again, getting rid of that negative 6, so my y is all by itself. Again, putting this in alpha y equals, so it will stay in fraction form if it ends up being a fraction. If it does not become a fraction, then it will just tell you what whole number it is, like 24 and negative 6 will be negative 4. How nice is that? Notice my slope is 2/3, my y-intercept is -4. Alright, now I'm going to graph. First thing I'm going to do is I'm going to graph this magenta one. So my y-intercept is -1, which is down here. Again, a final time for you to pause the video, graph them on your own, and then tell me what the solution is. So I've just graphed the first point of this one, but again, it's a great time, third time, to pause the video and try it on your own from here. Alright, if you're sticking with me, then maybe you're ready to go over this. Alright, so y-intercept is -1. I have to move up 2 and to the right 3. That's 2/3. 2 and to the right 3. Up 2 and to the right 3. And then to go the other way, down 2 and to the left 3. Down 2 and to the left 3. I like to put all the points on the graph because if I put all the points on the graph, if they're going to touch, they're going to touch in exactly one of these points. So it's a good idea to graph each one. And then when you're done, you're going to want to label. Sometimes I like to label at the very end. Maybe I'll wait on that. Let's graph at the end. Second one, my y-intercept is -4. 1, 2, 3, -4 is here. Slope again is up 2 to the right 3. Up 2 to the right 3. Up 2 to the right 3. And then backwards down 2 and to the left 3. Down 2 and to the left 3. Down 2 and to the left 3. Alright, so now that they're both graphed, I'm going to label my blue one with the original equation. I'm going to label that magenta one with its original equation as well. And yeah, solutions. What about the solutions? These lines don't cross. Guess what? We talked about this the other day. We have to actually write the word no solution. There is no answer. These lines don't cross. All that work for no lines crossing. Oh well. But if they did cross, you would have to identify and write down somewhere down here where they cross. That would be your answer to this, solving the system of equations graphically. All right, looking forward to seeing you in class tomorrow. Good luck.